Bonjour. Hello, everyone. I would like to officially thank all of you for participating in this first edition of the Collège de Paris Colloquium on blockchain technology and value chain performance. This is indeed a first edition. I hope there will be many of these in the very near future. There will be two different sessions in today's organization. This morning, we will hear from our researchers from our own establishment, as well as from all over the world and several universities. While this afternoon will be a time for debate on an open table format. Without further ado, I would like to introduce Olivier Delagarde, our president, for the opening speech of today's
Hello to all. I am very pleased to welcome you this morning for these study days devoted to the blockchain's contribution to value chain performance. I am looking forward to this scientific, international and professional day. This conference is a first for Ascensia Business School. I would like to begin by thanking the Ascensia Scientific Committee, which has been kind enough to encourage and sponsor the event, in particular its president, Professor Nicolas Berland, and its vice-president, Professor Eric Séverin. I also salute our professional partners. First of all, the company SmartChain, a recognized French specialist in blockchain and co-organizer of the symposium. Then, the association DIAF, which supports research in the field of actuarial and data science. Special thanks to Adrien Hubert from SmartChain for his friendship and his trust. I would like to thank also our academic partners, University of Weston in the United States and its president, my friend Vinay Lamba, and Rajagiri Business School in India. I would like to point out that this Blockchain Day is the first part of a two-part scientific event dedicated to technological innovations for value chain performance. A second day dedicated to business analytics will take place in Rajagiri in India on March 23rd. I invite you to connect to this event also. Finally, I would like to thank the organizers who made this possible. Guillaume Fink, who took on this project with his usual enthusiasm, kindness, and dynamism. Marine Guichet, who took care with talent of the communication for the event. Maxime Maury will brilliantly ensure the technical coordination. I insist in conclusion on the three dimensions of this event. First of all, it's a scientific day. That is part of one of the two axes of Ascensia Business School research policy. Secondly, it's an international event, and I am very happy of this. Contributors will speak to us not only from Paris this morning and this afternoon, but also from Lebanon, Nigeria, Dubai, India, USA, Lithuania, Tunisia, or Ecuador. And finally, it's a professional day. The innovations presented and made possible by the blockchain are intended to be applied in different environments, including within our schools, as I will reveal this afternoon. Good day to all of you.
Thank you very much, Olivier. Our first speaker is called Noor El-Maddoul. Noor is an associate professor at EPITA and an associate researcher at Sorbonne University. Before joining EPITA, Noor was an associate professor in cybersecurity and responsible for the engineering cycle and digital security and network at Digital Security and Network at Paris. She received her master's degree in networks and computer science from Sorbonne University, Telecom Paris Science from Sorbonne University, and her PhD in cybersecurity and computer science from Sorbonne in cybersecurity and computer science from Sorbonne. Noor, welcome. 28. You are the first speaker. Noor, not an easy task. You are the first speaker. Not an easy task. The word is yours.
So thank you very much, Guillaume. Thank you for this presentation.
Thank you very much, Guillaume.
Hello everybody.
Presentation.
Hello everybody.
And today, I will present for you a general abstract about the paper entitled "Secure and Internetless Connectivity to a Blockchain Network for Limited Connectivity Blockchain Network for limited connectivity bank users. About this paper, in fact, it was published about this paper, the 6th International Conference on Mobile Secure and Programmable Networking in 2020. It was co-written by 4 authors. The first author is the PhD student Daniel Maldonado-Ruiz from EPN, and it has the possibility today to present for you another of our published papers. The second author is the Professor Mohamed Badra from Zaid University, and finally the Professor Ginny Torres from EPN. So I will talk about our current situation today. As you know, we have today smart devices. We can use them in order to access the banking services, in order to access the banking services, perform financial transactions, via financial transactions. However, we can see that we cannot access to these services, and also we cannot perform any payment transactions without having a stable internet connection. So if we are in the offline internet connection, or for example, if we use a classical phone, or for example, if we use a classical phone, there are several banking solutions that integrate the blockchain infrastructure in order to perform financial transactions, but all these solutions use or need to use a stable internet connection. So in this slide, I present for you some solutions that integrate the blockchain technology in order to manage financial transactions. In order to manage financial transactions, maintain the validation of these transactions in the online mode, and none of them deals with the case when the smartphone is in the offline mode. When the smartphone is in the offline mode. For more details about this proposed solution in the state of the art, I advise you to read the full paper. So I advise you to read the full paper. What is our proposal? Our proposal is to create a new blockchain-based system with a distributed trust that allows to validate in a secure and reliable manner the payment transactions in the offline mode for the client, or also if the client uses a classical phone with 2G. So our proposal is based on 3 main actors. The first actors is the mobile device that does not have any connection to the internet or a classical mobile device. The second actor is the mobile operator that acts as a certification authority, and then it is considered as trusted third party in our architecture. And we have a blockchain infrastructure, and for me in my slides I will not remember you what is the blockchain technology, but I think that the next presenter will remember you what is the blockchain technology. It is the distributed ledger. So now in order, yes, good. So in fact, how it works for our architecture. So in fact, the mobile operator and the mobile device can communicate together classically thanks to SMS messages, okay? And the mobile operator is a server, and it has a private key, and this private key will serve to sign the SMS messages. And also the mobile operator has a certificate which is stored on the mobile device. And this certificate will be used afterward by the mobile device in order to verify the signature sent from the mobile operator. So here, as we can see that the mobile operator is a server, is a trusted third party for our architecture, and then it has a stable internet connection, and then it can communicate in a very easy manner with the blockchain infrastructure, or also with any existing system as the banks. So this is the data for our proposal. Now, in order to explain for you the general idea or the general context of our proposal, so I present here in this slide just the general abstract, but for more details it's necessary to read the full paper, because I want to stay in very general. Okay, So in fact, so here, if we will assume that we have a client with his offline mobile device, and this client wants to perform a payment transaction, or for example, he wants to access to a bank service. So in this case, there is no connection, but what he will do with our proposal, he will send a classical SMS message to the mobile operator, and this message will contain the information of the transaction. Firstly, the operator, because it's a trusted third party and he has a stable connection, it will communicate with the system responsible for the transaction, as for example, the bank, in order to get an authorization for the transaction. Secondly, the operator will inform the mobile device by this authorization thanks to a signed SMS. And in this case, by getting this signed SMS, the mobile device will verify the signature thanks to the public key of the operator, getting from the certificate. Then the operator will communicate with the blockchain infrastructure in order to create and validate the transaction for ensuring the specific properties as traceability, integrity, etc. And we note that all the transaction that will be stored in our blockchain infrastructure will be encrypted in order to ensure the confidentiality and to ensure the privacy of our transactions. So finally, after creating the transaction on the blockchain in a distributed manner, the mobile operator will answer to the mobile device by sending also a new SMS message signed thanks to its private key. And in this case, the SMS message will contain the identifier of the transaction on the blockchain. So in fact, so our proposal is based on in several models and in several procedures. And here in this slide, I give for you just our transaction model. So it is based, in fact, in the smart contracts. So as we can see here, we have our blockchain network. So we have several nodes, and the mobile operator is considered as a node in our blockchain network. And it is also considered as a gateway for the mobile device. And all the operations in our proposal are based on a smart contract, which is deployed on the set of the nodes in order to automate the exchange. So finally, I will conclude this presentation. So our proposal, in fact, aims to ensure secure payment transactions and the secure access to banking services for offline mobile devices. Our proposal is based on the blockchain technology in order to store the history of all transactions in a secure manner and in a distributed trust. And also we note that our proposal ensures the privacy of the stored data by encrypting them. So here I put for you the link for the original paper, and for more details, so you can consult this paper. And if you have any questions, so I'm here. Thank you very much for your attention.
Noor, thank you very much for this very clear and very insightful presentation. I have one question I wanted to ask you. It is specifically in regards to internet-less connectivity. Do you see in the future a development of blockchain in specifically nations that have difficulties with internet networks in general?
Yes, in fact, the proposal of our proposal is to help users that either does not have connection or if they have difficulties to connect to the internet. So the both. But here in my presentation, so I presented in general manner, so without any connection. But yes, if the user has difficulties, so our proposal can help the users in order to perform payment transactions, purchase, or also to access to any service without needing to be dependent to a connection, an internet connection.
Thank you very much.
Our paper also is it's not only to provide for the users banking transactions or to access the service, but also to store all the transactions on the blockchain. Because here, if I come back to my architecture, so here you see that we have the mobile operator here, and the mobile operator is connected to the blockchain infrastructure, but also before that the mobile operator store any transaction on the blockchain, so it needs to already authorize the transaction from the classical banking network. So it is an hybrid architecture.
Thank you very much, Noor. We really appreciate this very clear explanation. And again, we thank you for participating into this colloquium. Have a wonderful day.
Thank you for you also. Thank you.
Thank you. Our next speaker is Yasmina Kashu. She is going to present a paper on blockchain technology and value chain performance, applications, and future directions. Yasmina is one of our DBA students at Ascensia Business School. Her doctoral research focuses on the importance of finding the perfect balance between modern and traditional ways of hospitality and maintaining a human touch with the rise of technology. After receiving her master's degree, she started working with Marriott International as a senior accountant. And following the outbreak of COVID-19, she has decided to continue her academic career with a DBA to reach a point where she can shadow other people to define true hospitality. Yasmina is joining us from Paris, live on our campus. Yasmina, welcome.
Sure.
Yasmina,
Thank you.
Go ahead and start your presentation.
We cannot hear Yasmina, please.
Now you can hear me? It's not working. Can you hear me now? So hello everyone. Before we start with the presentation, I would like to ask you some key questions. Can you see the presentation? Yes? Yes. Can you see the slides? Oh.
That's good.
That's the slide.
Yes, the slide is on the live, yes.
Oh, okay. So I would like to ask you some key questions before we start. So for instance, when was the last time that you had bought a luxury brand item like a pair of glasses or a watch? How could you tell that the item you bought is genuine? Or for instance, when was the last time that you had a salad? How could you tell where the lettuce came from? Or what if you're having wine? How could you tell that the wine that you're actually drinking is really the one that should be there and it is not counterfeit wine? How could you tell the provenance of the grapes that are really inside the wine? Are they organic? So all of these are key problems supply chains are having challenge with. There are a lot of vulnerabilities that supply chain and supply chain management today, and blockchain technologies are used as a way to make supply chain more secure, more transparent, and more efficient. And that is what we will be covering in this presentation. I would like to start with supply chain. So supply chain is, as you all know, is all the steps involved in getting products from raw material to the customer. In other words, it's how you take the raw materials, you transform them into a product, and then you get those products into the hands of the customer. This is supply chain management. And the goals of supply chain management are multiple. Among them, to fulfill demand efficiently, also to drive customer value, and what's meant by that, to make sure that your customers are always happy, because if you have customers happy, you will have repeat customer, and this is how your business will grow. Also to improve and maintain responsiveness to any type of change that are happening in the business overall, and to contribute to financial success. Well, this is an integral part of any business today. But there are a lot of key challenges in supply chain management today. First, we have the multiple separate players, and a supply chain can contain hundreds of steps. And sometimes these are placed across vendors that may be in different places around the world. So these multiple separate layers, they lack of transparency because each one of them contains and controls a certain amount of data pertaining to what they add into the supply chain. So as a result, there are a lot of discrepancies in record. There may be a supplier that has an information that you believe is accurate, and then you find out that the information is not correct because it does not match the information that you have at a different database. So multiple separate layers and lack of transparency, they result in discrepancies in record. And this is the key problems because they can be also subject to tampering and somebody modifying the data. Another key component is globalization. As the world becomes more and more globalized and companies keep adding more and more global players, they may be sourcing their raw materials from different places around the world and using various global players. So all of these affect the goal of maintaining high performance, and because ultimately if you cannot maintain a high performing supply chain, the end result will be that you'll have unhappy customers. And there's also another key component that is affecting supply chain is the issue of counterfeiting. So what is blockchain? This technology is making headlines everywhere. Yet for many of us, it is a concept a little bit difficult to grasp. This technology has been proposed for many problems in many industries that were having problems in keeping it up. So today we're going to try to unpack blockchain at the basic level and look in more details at its impact on supply chain management. Blockchain was integrated into the world and was popularized by the cryptocurrency Bitcoin. The technology behind Bitcoin is still a mystery for some people on how it is, what it is, and how it was integrated into the digital world. It's very important to understand that blockchain is not Bitcoin. Rather, it's the underlying technology to cryptocurrency, and blockchain has also many other possible uses. So blockchain, it's a data structure that stores data chronologically in blocks, which are chained together in a continuously growing series. So, as I said, it's a growing list of data blocks that are linked together. And the records that blockchain keeps are called blocks. Think of it as a steadily growing spreadsheet of records that create an immutable record of blocks linked to the previous block using the state-of-art cryptography. A blockchain can be programmed not just only for financial transactions, but also anything that holds value and can be expressed in codes. Anything from birth to death, marriage licenses, education certificate, insurance claims, votes, really the possibilities are truly limitless. So how does it work and how it is applied to supply chain management? First, blockchain is decentralized. I will give you an example. We determine how a dollar is fake, how a dollar bill is fake or valid today, due to the serial number on it that the banks keep records of it. Whenever you want to prove that a document is legit, you just check it up with the relevant authority. So all of the letters are all centralized, meaning that there's a central authority that can manipulate or corrupt the data. One of the advantages of blockchain is decentralization because all the transactions are done with the consensus of all the users. So decentralization, it decreases the risk of manipulation, fraud, and corruption. It works by using distributed ledgers and storage opportunities that are stored in blocks on the network rather than relying on a single database. In any business model today, there are a number of participants that need to exchange data and document. And often in order to increase efficiency, these participants have attempted to exchange the data and transact them among themselves using a central ledger. This is a great model. However, it has few drawbacks, namely putting a lot of power in the hands of whomever owns that central ledger. The blockchain business model is designed to eliminate centralized transaction by using a distributed model instead. and giving everyone access to all of the data, which is extremely resistant to tampering. So it could solve problems of trust and the way we share the data. How does it apply to supply chain management? Well, when blockchain technologies is applied to supply chain, the potential improvements are obvious because every participant from retailer, manufacturer, transporter, distributor, and even the customer, they all have access to one link, encrypted and validated information set, providing everyone involved with elevated efficiency and guaranteed data integrity. Also, it's a peer-to-peer transmission, meaning that the communication happens between peer-to-peer and not with the central authority, so it helps with transparency and accountability. Because the ledger is decentralized, all peers involved in the transaction network can view it. So it provides transparency to all. Blockchain technology has the ability, provide us the ability to trace goods on the platform, on the network that were recorded by all the users, which are in return tamper-proof to ensure the data integrity. So it provides more visibility to customers and companies because they can manage and monitor risks within the supply chain management, ensure quality delivered parts, and track the status of the delivery order. So by using blockchain technology, companies can finally have a completed picture of their product at every stage within the supply chain, bringing transparency to the production process while reducing the cost of manufactured goods. To give an example, a retailer can check on the platform where the products are, if they are with the distributors being packaged and shipped. The retailer can also check if the products are damaged and if they were sent back to be fixed and when will they arrive. So blockchain can help improves the communication between parties and builds an overall efficient process. Also, there's the real-time visibility and reporting. The biggest pitfalls in supply chain management are the execution of errors, including inventory mistakes, duplicate payments, and loss of shipments. Blockchain technologies identify all elements and every step within the supply chain management process, which makes it easier to spot mistakes and to adjust them instantly. I will give another example. If a shipment of lettuce has been found spoiled, a blockchain ledger will make it easier to spot to trace the contaminated batch history all the way back to the farm where it came from. And then a cross-reference action will take place to check everything that came into contact with. We have the smart contracts. As we all know, contracts are always used in business and they have been there for a really long time. But if something happens and someone fails to perform their part in it, the other party has to assign an attorney to help persuade them in terms of payment, and this could be really costly and time-consuming. So smart contracts are here to make supply chain much simpler and more transparent. The idea is to create a single source of data products in a supply chain. And once the contracts are set up, they are automatically and digitally executed in terms of payment and other related terms. Finally, we have the security. Blockchain technology is built on highly secure blocks. And as we have mentioned before, that all transactions are stored chronologically and linked to the previous block. So no one can hack the information on the platform because they would have to change hundreds of copies at the same time, which is really impossible. Cyber attacks are increasing more and more, and they are becoming regular these days. This is a clear reason why supply chain are using blockchain as an ideal solution to make sure that their data are guarded against any cyber attack. I'd like to give a real-life example about Natural Farm. So sorry, something happened. So Nature Farm. Okay, sorry. So Nature Farm uses a blockchain platform to track the blueberries from the point of harvesting to reaching the client. As we are witnessing that technology is blending with agriculture. So farmers use QR codes to open crates of fruit as seen in the picture. And that remains all the way to the store. And then a customer can then use their smartphone to track where the blueberries were grown. And this is for a very important reason, because freshness is imperative to keep people healthy. The IT director of Nature Farm was explaining that today's supply chain is very manual and delays along the way threaten the food's freshness. There may be delay from anywhere from 4 hours to an air shipment to 2 days for a boat shipment and for the products to get cleared and go through customs. So blockchain is really important for farmers because they can openly record their data, and customers, on the other hand, can digitally track the food along the way and have a proof of the entire process. Now we have talked about the advantages of blockchain technology, but there are some limitations. First, there's the irreversibility of records. Blockchain is immutable. And this is wonderful because it keeps the integrity of a record where nobody can tamper with it. However, it's horrible if someone wants to go back and modify anything or do some reversals. For example, if someone processes the payment and wants to go back to modify the payment while using blockchain, that would be impossible. Also, there's the private keys. To proceed with any transaction, you need the private key. Although all users can see your public key, the private key is much more important. Therefore, it must be highly secured, because if you lose the private key, you will lose access to your funds, and there are no other way to recover them anymore. There's also the limited pool of technical talent. There are not a lot of developers that have special expertise in blockchain technologies, because it's a relatively new technology and a new concept, and there are not a lot of developers that can work on this technology. So finding the right pool of technical talent of developers for a project can become a little bit hard. And also, we have the cultural disadvantage because all business models, they are already implemented and they have been running on a particular architecture for some time. And this innovation may threaten and changes somehow the system and how it works, so it can lead to a disruption in the industry. To conclude, as we are witnessing today, more than ever, the supply chain is evolving and becoming one of the most active parts of blockchain take-up. Blockchain is changing, supply chain is changing, and blockchains are increasing more the efficiency and transparency all the way from the warehouse to the payment. What it might look like in 5 years from now is very different from today. Uncertainty is a big word, and we face almost uncertainty in all of our daily transactions, where blockchain can really play a role. We face uncertainty like not knowing who we are dealing with, not having visibility into a transaction, and not having recourse if things go wrong. Blockchain technology is not just an economic evolution, but it's also an innovation in computer science. It provides us with the technological capability of creating a record of human exchange in a new way. It does this in a decentralized way by converting our uncertainties into certainties. Thank you.
Thank you very much, Yasmina, for this very interesting presentation. Congratulations. I have a question for you. I was wondering, since you have a specific focus on the industry of hospitality, if you see in the very near future or already today in place, specific applications of blockchain for the hospitality industry?
It's a very interesting question. Blockchain technology can really play a big role today in hospitality management, especially with when integrating the IDs and passports of guests at the check-in. They could really ensure the transparency and integrity of the records in the industry. So I think when hotels start implementing blockchain to their system, it might be very efficient, especially for the transparency.
Thank you very much for this very clear answer. Yasmina, thank you for participating in our colloquium. Have a wonderful day. Thank you. And I'm very pleased now to introduce our next speaker. Her name is Anastasia Duchesne. She is going to discuss with us TSS and cryptography on blockchain. She is a researcher collaborating with SmartChain, one of our sponsors. Anastasia received her master's degree in engineering from ECE Paris in the fields of IT and cybersecurity. She is currently a PhD researcher in blockchain technology and security, and she leads the cryptography threshold signature scheme, TSS, for SmartNode. Anastasia, I would like to welcome you to this colloquium. The microphone is yours.
On trouve votre PowerPoint, on arrive.
Hello, Anastasia.
Yes, I'm
if you are ready, we are too.
Yeah.
Excellent. It goes without saying that Anastasia is joining us from Paris. Our next speakers will be joining us from far away, actually, because we have this morning two speakers joining us from Nigeria. We have one joining us from the Middle East, Dubai, I believe, and we have one joining us from Ecuador in Quito. So this is truly an international event, and I'm very thankful to our technicians and the entire staff who has helped us prepare this, because as we can all see, it is sometimes a bit complex to master the technology, to have all of these people from all over the world join us. And so thank you very, very much, Maxime and Marine, for making this work. Anastasia, you can give us a sign whenever you are ready. We'll be listening to your presentation.
So today I'm going to present to you how to improve the security and resilience of private keys in a decentralized environment, which is the name of my thesis. So, okay, perfect. So, the fast developing of the blockchain permitted the emergence of a new decentralized economy based on digital assets called tokens. Compared to a centralized economy, peers can exchange value without going through a trusted third party. The blockchain is a virtual shared ledger applied to a peer-to-peer network composed of groups of computers, also called nodes. Each node in the network has its own copy of the ledger. The transactions carried out on the blockchain network are verified, immutable, digitally signed, and timestamped. This is all possible to a set of private key and public key, which are based on asymmetric cryptography. The private key allows you to sign a transaction and derive the public key, which is publicly available and allows you to verify the signature of a transaction. From the public key, you can derive the public address of the transaction. This is a one-way function. You cannot, for example, derive the public key from the public address. We can only go from left to right. So the thing is, keeping the private keys on a decentralized environment is very hard and is a huge challenge. But why? So let's do a quick comparison with the banking system. So on the blockchain, you have a private key, which allows you to have a direct access to your funds, which is a bit different in a banking system, because in fact, you have to authentify into your bank through your credit card or your password, and it is your bank, which is a trusted third party, that will allow you the access to your funds. But if you don't have the password or the credit card, the bank cannot allow you the access to your funds. But it is pretty easy to ask a new credential, to renew your credentials to your bank if you lose them, and again, you will be able to authentify yourself to the bank and access to your funds again. But what happens if the bank disappears? Well, if the bank disappears, your funds will disappear too. And the thing is that the blockchain, you cannot just turn it down. So it is pretty immutable in time. But what is the blockchain private key loss conundrum? I guess we all saw this kind of headlines where the Bitcoin hit his all-time high. People complaining about the fact that they lost their private keys and that they could not access to the funds, and their funds are maybe locked forever on the blockchain. The thing is that, I repeat it again, the private key allows you a direct access to your funds. So if you lose your private key, you don't have access to your funds anymore. But it is more than that. Actually, your private key represents the ownership of your funds. So if you lose it, you lose the ownership of the funds, which are free and locked forever on the blockchain. So there are several solutions that do exist to protect and keep your private keys, but none of them are foolproof. One of the techniques consists in one person self-managing their private keys and thus being self-responsible for keeping them safe. The thing is that keeping private keys requires a high security key management, having two main factors. The first one is to prevent oneself from losing their own private keys, and the second one is preventing others from stealing your own private keys. So one of the solutions is just to keep your private keys in a file on your computer, for example, or your phone. But the thing is that you can break them or lose them, and thus you won't be able to access the files on it anymore. And if you can't access the files, you cannot access your private keys. Also, both of these types of devices are connected to the network and thus makes them vulnerable to the cyber attacks, such as phishing or even malwares. The second solution is just to note them down on a piece of paper or even just print them out. The thing is that you have to keep those keys for several years, and God knows how it's hard to keep just a single piece of paper for years. Yet you have another solution, which is to put your private keys on a piece of hardware, such as an USB key or external hard disk, for example. But still, you can lose them, they are damageable, and your hardware provider is never safe from cyber attacks himself. In fact, this summer, Ledger, which is a well-known hardware wallet provider, was a victim of an e-commerce data breach attack during the summer and had a significant amount of users' data that were leaked, which then led to some phishing attacks. Another technique consists in entrusting your private keys to a trusted third party, cryptocurrency exchange. This solution is called custodial. This means that you don't have to manage your private keys anymore. The exchange does it for you. But the thing is, if you don't have a full control over your private keys, you don't have a full control over your crypto assets. And it also means that if the exchange one day disappears, you won't have access to your funds anymore. And this is not different from a traditional banking system. So the last one technique is solutions based on protocols of a huge family, which is called a multi-party computation. This is a cryptography branch, and it is when peers decide to compute a function altogether with secret inputs and a correct single and public output. So to explain this, let me tell you the story of the two rich millionaires that the richest one paid the dinner, but they didn't reveal their wealth. So we have Alice, who has a salary of 250,000, and Bob, who has a salary of 150,000. They do not want to reveal their wealth to each other, so the secret input is going to be their salary. They're going to put it in the huge black box, which is the MPC. It is only going to compute the maximum of the salary and output the name of the richest one, which is, in our case, Alice. So here you go. You have a secret input, the salaries, a function that computes it for them without never revealing the secret inputs, and the public output, which is the name of the richest one, in our case, Alice, who is going to pay the dinner. So the three main protocols that are used on the blockchain and a part of the MPC family are multisig, channel secret sharing scheme, and threshold signature scheme. So to illustrate better how the process and the functioning of these protocols, I'm going to talk about keys, which are the private keys, obviously, locks, which will represent like a key in a lock is the process of signing something on a blockchain, and of vaults. So if you manage to open a vault, you manage to produce a valid signature. So in the case of multisig, you have as many keys as you have participants, and you have as many keys as you have locks on your vault. So it means that if you have 6 participants, you will have 6 keys and 6 locks on your vault. This means that you need to have a big vault, which makes it way harder than a normal vault and more expensive. This is the case of transactions. The multisig transactions are done on-chain, and they contain all the signatures of the participants, making the transaction containing all the transactions more heavier than a normal transaction and thus more expensive. So the problem with multi-signatures is that it also gives out information about the participants in a network, because if you come into a house and you see a vault with 6 locks, you know that you have to find 6 keys to open it. So this is the same case on the blockchain. You see a transaction with 6 signatures, you know that there were 6 participants in the transaction. The second protocol that is part of the MPC is called sharing secret scheme, a sharing scheme. So this is a protocol that involves only 1 key and 1 lock, which is way lighter, and you don't have any cost problems anymore. So you have a dealer which will create the key for you and divide it into several parts. So let's say 6 parts for 6 participants. Once he done dividing the key, he will just distribute the parts, and each participant will keep his own part of the key. And when the participants decide that they want to sign a transaction, they will go back to the dealer, give their parts to him, he will assemble the key and open the vault for them, so signing the transaction for them. And here you are with a single transaction and without revealing the number of participants in the network. But the thing is that this dealer is the single point of failure of the key, because when he has the key and he assembles it, the key is in one piece, at one place, at one time. So someone can just steal it at that moment, and you are never really secure or safe from the dealer himself being corrupted. So here we come to the third protocol, which is called the threshold signature scheme, and that emerged in mid-2018 with the blockchain private key loss conundrum problem. So this is one of my favorite protocols, and the thing is that you don't speak about private keys anymore. During this protocol, you speak of secret shares. So each participant has a secret share that is generated in a distributed way. This means that you never have all the secret shares at the same place at one time. So you get rid of the single point of failure problem. So each participant will have the one secret share, and they will define what is called a threshold. Like, for example, there are 6 participants in total, but they decide that there's only 3 participants, only 3 secret shares are required to open the vault. So this resolves the problem of, for example, someone losing their secret shares, because as long as you still have the required amount of secret shares in the network, you still can open the vault, which is pretty nice. And finally, in order to open the vault, to sign a transaction, you are going to do a distributed signature. This is similar to a relay. It means that, for example, the first all participants will take turns, put the key in the lock, turn it a bit, and take it out. And it's only the third person, the last person, or turning his key in the lock, that is going to be able to open the vault, because it is the combination of all the 3 keys turning in the lock that opens the vault. And thus you never have all the 3 keys at the same time, at the same moment, and you don't have the single point of failure anymore. It has also another really cool feature, which is called the proactive key rotation. It means that if the group decides to get rid of their old keys and generate a new set, they can, and it will always open the same old lock. So this is pretty cool, because it is actually comparable with removing your password every 30 days, which is practice of cybersecurity hygiene, for example. And it's also cool because if someone loses their key or gets their share stolen, they still can just generate a full new set of keys and the problem is solved. But it also comes with new types of attacks and security problems. In fact, it is sensible to Byzantine generals problem, which means, in other words, that what happens if the participants in the network are dishonest? Because let's say if someone decides to put a wrong share during the signature, or like the wrong key in the lock, the whole process, signing process, will be invalidated, and you will have to restart it again from 0. And thus it can make you lose time and prevent you from opening the lock or signing the transaction. Also, since you have a required amount of people online, you need that, for example, if we need 3 people to sign the transaction, those 3 people will be online at the same time. And if they are not, you cannot start your signing process, which means that you have disponibility and availability needs, and thus this is pretty problematic. So these problems and these challenges are the one I'm trying to resolve during my thesis. And well, thanks for listening. Yes. So for the first question, you basically can record anything on the blockchain, but you have to keep in mind that you have to put it in a transaction, and the biggest is your asset on the blockchain, and the heaviest is going to be your transaction. This meaning that the heavier it is, the more expensive it's going to be. So for now, for example, we only tend to keep the hash of a file of the transaction instead of keeping the file itself to prevent the transaction from being expensive. And the second question, to me, what makes the blockchain pretty secure is that it is a network. As I told you before, it is a network made of nodes, and actually, the more there is nodes in a network, the more secure it is because there is more people to validate the transactions and also to keep a record of the ledger. And the thing is that it's almost incorruptible because in order to corrupt a network, you have to have more than 51% the control over more than 51% of it, which is pretty hard to do. And also, people are pretty motivated to participate in the network and to secure it because they are incentivized. They have rewards when they do the job in a good way. Thank you. Thank you, you too. Goodbye. Thanks.
Students, doctorate in business administration. He is also a new faculty member at Ascensia Business School. He holds a master's degree in business administration and a Bachelor of Science in management information systems from the Lebanese American University in Beirut. His professional experience extends over 15 years in the Lebanese banking sector, mainly within the fields of performance management and business analytics. He also served as an adjunct faculty at a higher educational institute in Beirut for about 9 years. Maxime, I think we can send the video now. Thank you very much.
Hi, I'm George. I'm a DBA candidate at Collège de Paris, and soon I'll be joining Ascensia Business School as part of their faculty team in Paris. However, for the past 16 years, I was working at a large financial institution in Beirut, Lebanon, at a bank as the head of performance management and business reporting for branches within the branch network division. In Lebanon, cryptos are not allowed. As per the central bank, people with cryptocurrencies cannot open accounts at bank to store them. Blockchain is an unknown term for many, and if known, it's even confused with Bitcoin and thought to be illegal. So in short, the blockchain concept in general is untapped. By the end of 2019 and beginning 2020, the economic situation in Lebanon was simply collapsing due to the start of the pandemic and other political issues. The banking sector was severely hit, and it was at a severe case. Soon after, a de facto capital control was imposed by banks, so all cross-border transfers were limited to the bare minimum, and cash withdrawals also. So people suddenly lost control, lost the ability to withdraw their own money. In my opinion, had cryptocurrency been circulating in the country, had blockchain technology been enabled in a way or another through financial institution, this would have not been the case. That's why I was triggered to know more about this technology, even though I'm not a perfectly technical person from this perspective, and to get to know its full potential and implementation. That's why in this presentation, I really aim to make blockchain easy for people who don't really know what. So my aim in this presentation is to briefly talk about blockchain from a non-technical perspective to help better appreciate its disruptive potentials and how its ability to change the business world and the way organizations work. Mainly, I'm going to talk about what is this technology, how it does work, its different type, the advantages and disadvantages, and surely the difference between blockchain and Bitcoin, which you probably all know, why it is important to talk about blockchain and to know about it and how it is used. Blockchain can be summarized in 4 main points. It's a digital ledger that keeps records of all transactions within a peer-to-peer network. The information are encrypted and every occurrence is recorded, so it cannot be altered. The peer-to-peer means there's no intermediary, no middleman, no central bank. The blockchain is decentralized, so there is no need for a central certifying authority. So technically speaking, blockchain is a distributed system that stores data and blocks in a continuous manner. Every block has a transaction information and is attached to the network through a consensus algorithm. That's why the name blockchain. The blockchain technology is actually a manifestation of the more general DLT technology. A less technical definition or explanation of blockchain. I really consider blockchain like a very special database. But unlike the traditional database that stores data in rows and columns, the blockchain stores data in blocks that are chained together. Each time new data is entered into a block, the block contains information from the previous block and attached to the network. And so it's literally a chronologically ordered blockchain. Typically, many types of information can be stored in a blockchain, but the most common one are transaction ledgers. The blockchain is decentralized. There's no single person or authority that has control over it. This decentralization is the most interesting aspect of blockchain. There is no central administrator, no central government or company or central banks that has control over it. The data in the blockchain are fully transparent and is verified by user consensus. Despite this transparency, also blockchain is incredibly secure. There is no central point of attack. The data is dispersed over all the blocks. It's very hard to attack it. How does actually blockchain work? You can see blockchain is somehow similar to an accounting software. Its basic function for a ledger transaction is to track the movement of value from point A to point B and record the transaction. Of course, old-fashioned double ledger accounting is completely not like the blockchain. There's no trusted central third-party authority in it, no audit for transaction or whatever. Let's see from a technical perspective, how can blockchain work? I need to go over this, then we'll simplify it a little bit. The blockchain are settled in batches called blocks. Every block has data from the previous block called hash. And every block is attached to the next block into a chain. To ensure control within the blockchain, the audit process is called mining. This is typical in blockchain and typical in public blockchain networks. Anyone with powerful computer can actually mine and participate in this process. As a reward for each for practicing in this process, the node is rewarded with a cryptocurrency, mainly Bitcoin. And this proof of work is what ensures that the transaction is verified. So the first block, it's called the Genesis block, is attached to the second block and third block, and there's a hash that connects each block together. This seems a little bit complicated, and it certainly can be. Let's make it simpler with a non-technical example. Assume you are a node and you have a file transaction on your computer. Let's call it a ledger. Two other accountants have the same file on their computers. The accountant, let's call them a miner, and since the file is distributed on other computers, it's a distributed system. If you want to make a transaction, your computer or you send an email to all the accountants to inform them. Now each accountant will rush to check if you can afford this transaction so that he can pay his salary. The first one to check or validate the transaction will reply to all other accountants, showing them his logic and verification, which is called the proof of work. So the other accountant will have to agree with him. This is the verification, and he will get paid by Bitcoin as a reward of his work. There are several ways to build a blockchain network. The two main ways are the public blockchain and the private one. The public blockchain is the typical broader one where anyone can join and participate, such as Bitcoin or Ethereum or whatever. Its drawback is that it requires a lot of computational power for the proof of work, and because of the transparency, there is little or no privacy. Enterprises or private company should consider this before getting into the blockchain. An alternative is a private blockchain. It's similar to the public, it's decentralized and peer-to-peer. However, this company has control in a way who participates and who executes the consensus. The private blockchain can be run behind a firewall and even hosted on premises. So it has many advantages of the blockchain with some control or limit by the company hosting it. Now, the main question, or it's a bit obvious, what's the difference between blockchain and Bitcoin? Blockchain has gained a lot of momentum recently, especially with the Bitcoin. The goal of blockchain is to allow digital information to be recorded and distributed. Bitcoin is simply a digital currency. It is a peer-to-peer electronic payment system. It's not the actual blockchain. The Bitcoin protocol is built on blockchain, like other cryptocurrency, like Ethereum or whatever. So in short, the blockchain is the technology behind Bitcoin. The Bitcoin is a token, is a currency, like Ripple, like Ethereum, like other cryptocurrencies. The blockchain is the ledger that keeps track of who owns these tokens, who owns these cryptos. You cannot have Bitcoin without the blockchain, but you certainly can have blockchain without Bitcoin or any other cryptocurrency. For info, Bitcoin capped recently in February 22 at $57,128. It is the highest price ever for Bitcoin to reach, especially after Elon Musk comments. Why it is important to know about blockchain? The blockchain technology is really much broader than finance or payment or whatever. It has a lot of advantages. It has potentially a disruptive influence on business model. It can allow, or it can offer businesses a new way to offer their services and even render some existing services obsolete. It is a technology that has tremendous potential to transform organization and definitely a way to shake up the entire organizational structure. Sectors like finance, medicine, manufacturing, and many others are beginning to invest in blockchains. The full mainstream global blockchain implementation is not really, we're not really there yet, but there is a need for a widespread adoption. The idea is still even worldwide, slowly emerging, slowly gaining momentum. Yet it's very important to be very well acquainted about it because definitely the blockchain is the new era in technology and in business. There are some pros and cons about blockchain. The advantages are obviously that we talked about. It is decentralized, it ensures transparency, it is safe and secure because no one can attack the blockchain network, and it's multidisciplinary. It can be used for several disciplines, for several sectors. It has though some drawbacks. I'm not gonna say disadvantage, some drawbacks. It is a bit overhyped. Sometimes companies invest in blockchain where in reality they don't really need the blockchain technology. Whatever they need can simply be managed by a regular database or a little bit more advanced data warehouse. So this is why they must carefully assess their return on investment. It has a high cost associated with mining. So much computational power is required, and sometimes some might argue that it facilitates illegal trading because it is allowed by anyone, because it requires no practical KYC for traditional money transfer, unlike banks. Some might use the chain, some might use the blockchain for Bitcoin and other to transfer funds for illegal activity or to fund terrorism or whatever. How is blockchain used? From a business perspective, it is very helpful to think that blockchain is the next generation business process. It is a collaborative technology where everyone can participate, and it, like we said before, it has the capacity to radically reduce the cost of trust and improve the business models. The blockchain technology promises to facilitate fast and secure international payment, and this is why Bitcoin has emerged. The most known use of blockchain is actually monetary transaction, but the technology is really reliable for other type of transaction. Here we are going to talk about some examples of blockchain implementation. The most common one is smart contract. Smart contracts can really replace notary, third-party mediator, attorneys, on everyone. It can set the way with people can coordinate with each other to make contracts, to make agreement without the need for a third party. They are automated and they have the potential to transform many industries. An actual implementation of smart contract is Kaleido, which were the first to implement such platform. Other way blockchain can be used is in banking. Banking is new to blockchain. They are a little bit, let's say, prudent in investing, but many are going through it, and it will be very helpful for them for cross-border payment. It will definitely significantly reduce the time and cost. Westpac is actually an Australian bank who partnered with Ripple in order to create a low-cost cross-border payment system. Other banks are gradually tapping into the technology like Deutsche, Barclays Bank, and BNP Paribas. The supply chain logistics, especially Walmart, is also a real-life example implementation of blockchain. It helps them allow to track the source of food and know the problem if it's occur over the entire supply chain. It's a very helpful way to track the supply chain management. Another way is the real estate. It's a potential way to manage the information about every lot without the possibility to be altered. It will give buyers and sellers concrete and reliable information. Atlant is a company that developed a platform for real estate management through blockchain, and it's a very interesting example. It tokenizes real estate property and assets and allow them to be traded like stocks. Voting is also a way that blockchain can be used. West Virginia and the USA in November 2018, they tested a way to voting through blockchain application. Although it wasn't that perfect, but it's an interesting test to look about. Healthcare is also a way that blockchain can be used. Medical chain use blockchain to facilitate the storage of information for patient health records in order to
a group of several speakers joining us. We have with us live from Nigeria in Abuja a team of researchers and professors working in cooperation with AfriHub. Emeka Uwanaka is a gentleman with an extensive experience in management, teaching, and research. He received his master's degree in economics and international relations from the University of Aberdeen and his PhD from the University of Abuja. The title of the research work that is being presented this morning is Blockchain Technology Adoption in the Nigerian Capital Market, Prospects and Challenges. Joining Emeka are Nsikak, Pius, and Robert. Welcome to the four of you, and thank you for joining us in this colloquium. The microphone is yours.
Thank you, Guillaume, and good morning to everybody. Just trying to confirm that you can hear me before I start. Good. Thank you, Guillaume, and good morning to everybody. Can you confirm audio before I start?
We can hear you just fine.
Okay. Good morning, everybody, and welcome. Speaking here from Abuja, my name is Emeka Wanaka, like Guillaume has introduced. I have with me Pius Owo and Robert Onyebula. Pius Owo is one of our faculty members at AfriHub Global Distance Learning Institute in Abuja, and Robert Onyebula is recently concluded his MSc in IT security. He works in the regulatory agency for the Nigerian capital market, which is called the Security and Exchange Commission. And so the paper we have today titled Blockchain Technology Adoption in the Nigerian Capital Market. We're trying to look at the opportunities and challenges involved in adopting blockchain technology. It's a part of the MSc research of Robert Onyebula, who works in the Information and Technology Department of the Capital Markets Regulatory Agency of Nigeria. And so we're going to look at, we're going to introduce the topic. We're going to look at some of the problems and the objectives that influence this research. We'll look at the methods that were used, the results, and the conclusion. But before we go into details, which Pius and Robert will do, I just want to give some overview of what the Nigerian capital market is like. Nigeria as a country is slightly over 200 million people in population, with a GDP of over 400 billion US dollars. And so it's Africa's largest economy. However, by size of capital market, it's about 44 million US dollars. And so it ranks second to the Johannesburg Stock Exchange, which is the largest capital market in the African continent. And so, you know, the previous papers have given us some insight as to what blockchain technology is all about, and part of what influenced this paper, looking at some of the benefits of blockchain technology. What will be the challenges that are preventing the wholesale adoption of blockchain technology in capital market operations in Nigeria? And so this is the broad overview of what influenced this research. I would pause here and then I'll allow my colleagues to take it up from here.
Emeka, can you confirm who is the next speaker? Is it Nsikak?
Yes, it is. He's just shared the screen now.
Oh, okay.
So he's going to continue. Yes.
Okay. Jessica, can you please make sure you open your microphone so we can hear you?
Hello.
Excellent. Yes, we can hear you. If you can just speak up a little bit, it'd be great.
Yeah, good morning.
Good morning.
Is it fine now?
Yes, absolutely.
Oh, that's wonderful. Okay, so my name is Sika Pius. So actually I own a PhD in cybersecurity from Malaysia. So I'm actually working on my research interest is in blockchain. So I'm not really the expert when it comes to capital market. So my colleague will really handle that. So I'll just go through some stuff that we have here. As my colleague said earlier, we are just interested in the Nigerian capital market for so many reasons. So first, I'll just quickly go through what blockchain is. A lot of speakers have said this already, so I'll not waste much time here. So first, I must say that this research is actually, it was survey oriented. So we wanted to actually see the barriers, what is really stopping the adoption of this wonderful and emerging technology in Nigerian capital market. So first we see here, we know that blockchain is actually an immutable technology that also ensures non-repudiation. And non-repudiation is a very important security feature because it ensures that transactions, when transactions are made by users, users don't go ahead and deny such transactions, which is very important in capital markets. So, and also it also offers things like integrity from the immutability feature of blockchain. So we also have a quick recap. We have types of blockchain. We have the public blockchain, which actually gives open access to all users. So it's referred to as permissionless. An example is a very popular Bitcoin, which we all know, and the Ethereum. For the private blockchain, it's actually permissioned technology. So it actually restricts access to certain individuals. An example is the Hyperledger and the repo. Now we also have what is known as the consortium, which is somewhat private, but in this case, access is given to a group of individuals, not really single individuals like with private blockchains. An example is the Coda and the Quorum. Okay, so we very popular characteristics of, there are a lot, but these are the popular ones, which is the decentralization, which actually eliminates the need for central authorities, which actually we see with normal banking systems, where one organization or like the cryptography, the public key infrastructure, where it's a particular authority actually manages public keys and private keys, which could lead to things like key escrow. But with blockchain, decentralization is achieved and transparency is maintained. Also, another strong characteristics of blockchain is the consensus algorithms, like the proof of work, proof of stake, which are used by popular cryptocurrencies. Immutability, like I said, it's a very strong feature of blockchain, which ensures that when once data is stored in the chain, it cannot be reversed. It has its pros and cons anyways, but with respect to data integrity, this feature maintains data integrity. Anonymity is another strong feature of blockchain, which it uses public keys and private keys in place of sensitive data of users and their identities. So this makes transaction done without fear of information leakage. The next is the autonomy. Blockchain actually ensures autonomy from the fact that different miners could validate a particular transaction before adding it to the chain. So it ensures that nobody has full control, though there is in theory the possibility of 51% attack, where one miner or group of miners could hijack the entire node of networks, but this is very rare. So this is just a brief overview of the wonderful characteristics of blockchain, which can be adopted in the Nigerian capital market when things actually go right. So looking at the security functions, because with the capital markets, anything that has to do with money, with stock, people are concerned about the security that they stand to get. So looking at that, we look at the first thing that blockchain offers, and this is the risk management. Of course, we know that with risk management, it mitigates the risk that could come from any capital market activities. Then we look at the minimum privilege, so it restricts access to a particular set of people. So by doing this, security is ensured. And then vulnerability management, it manages a lot of vulnerabilities by ensuring authentication and encryption, which are all features and functions of blockchain. And then patches management. So when developers imbibe or adopt this technology, they are sure of like giving updates on their codes, on the application. This can our firmware, anything you build, you can just send patches in a secure and authenticated manner mode using the blockchain technology. So there are so many advantages of blockchain, as we all know, but there are also challenges and issues with blockchain, which also make capital market operators wary of actually adopting this technology. First is the issue of scalability. Scalability, especially when dealing with public blockchains like the Bitcoin and the Ethereum, which we all know, where it doesn't restrict access to a particular group of users. So this, when users grow, which definitely they will, and the nodes increase, data increases too, we are worried about the scalability of blockchain. How can it handle this data, the sizes of this data? Because like in capital market, we are dealing with almost big data, a lot of data coming. So how can it scale in this respect? And so we like, for example, we know Bitcoin, the block size for Bitcoin is about just 1 MB. So how do we handle data which it's more than this? This is also a challenge when adopting this in capital markets. The next is the issue of security. Yeah, blockchain offers integrity as a feature, non-repudiation, authenticity, but there's still the issue of confidentiality. Most transactions that are made with blockchain technology are actually done in plain text. Encryption is not really done on transactions. So this also is a problem with respect to security. Then we also have the problem of privacy, in as much as sensitive data of users, or what we call PII, that's the personal identifiable information of users, are not being used in transactions. But there is still a chance of de-anonymization of identities of users from after being ensuring anonymity. And this is also a challenge because users still worry that their sensitive data, like their information, their identities, can still be revealed even with the use of blockchain. And then there is the issue of ethical challenges, because most regulatory bodies they want to know actually who and where particular transactions are being made. And this is a very big issue, especially in Nigeria. Like our central bank right now, it's having this regulatory issue of ensuring the use of blockchain, for example, in Nigeria, because at times we want to know the identities of who is doing what kind of transaction and the amount that is being done. So ethical issue is still a problem in blockchain technology. Then we go to the fantastic applications of blockchain. Blockchains can be applied in so many areas of walks of life, from Internet of Things to the supply chain, which one of the speakers said earlier on. And then the issue of healthcare, blockchain can be used in defense, in automobile, a lot. But our interest in this case is with finance. And then the financial institutions over time have adopted blockchain, and they've seen a lot of goodness from this. So our interest at this point is in the aspect of capital market, how blockchain is used. We can also use, blockchain is also used a lot in the fintech, which will not really delve into that at this point. So our interest here is with the capital market. So next, at this point, I will pause and then hand over to my other speaker, which is the expert when it comes to capital markets. He will now tell us how blockchain can be adopted. Like I said, this is a survey-oriented research. And then I will now come back, and then after discussing the data and how the data will be collected, I will now discuss how we'll analyze and the result and the findings we found out from the analysis. Actually, we're going to use a chi-squared statistic to actually analyze the data that we'll get from, because we are going to send out survey questions electronically to the market operators to actually get their ideas and responses on how the barriers and the prospects of blockchain technology adoption in the Nigerian capital market. So at this point, I'm going to hand over to my co-author to throw more light on the capital market, Nigerian capital market, and the way the questionnaire was set up to get the data, and then I'll return to finalize the presentation. Thank you. Over to you now, Robert.
Okay. Hello, good afternoon. Hello, good afternoon.
Hello, Robert. We can hear you very well. You can go ahead.
All right. Thank you very much. My colleague has done quite a bit of work on what we were talking about essentially. Most of what we've talked about in blockchain has already been discussed previously, but I'll try and just give a bit of highlight on the capital market in Nigeria particularly. The capital market is a place where surplus funds are invested. So if someone has a bit of money, he wants to put it somewhere, he puts the money in capital markets. You buy shares, you buy stocks, you buy debentures, you buy bonds and equities and stuff like that. So basically, the Nigerian capital market is an evolving capital market. We are talking about derivatives currently in the capital market. And then if these things are coming up, there has to be, hello, am I there? Hello? Can you hear me?
We can hear you fine, but your presentation went off screen. Can you try and reshare your screen again?
All right. Let me just quickly do that, please.
Thank you.
Just a second, please. Can you see my screen now?
Yeah, it's perfect now. Thank you.
All right. Okay, so I talked about the capital market and then what it does. In every financial system, you have the capital markets where you talk about shares, where you talk about debentures, equities, and bonds. So what we're trying to do here is that what can we do to make what's on ground actually much better than it already is? Of course, there's already a functional system on ground. We have a clearing system. We have something that works. But can it be better? When you look at an evolving technology like the blockchain, it can actually make things better. How can it make things better? We have asset servicing, derivative transactions, and data security. I already talked about derivative transactions because every time we evolve, we add new things to what's already existing. Equities and bonds, there are also some things that we can also add to make it a bit better. So how can the Nigerian capital market key into this blockchain technology? Let me quickly run through some points I have here. Now, we have a challenge of infrastructure, we have a challenge of technology in our system. The paper tried to look at how people can actually view this new technology. In an emerging economy like Nigeria, a lot of people have a challenge of, oh, something new is coming up. Can we actually flow with it? Can we adapt to what is coming up? Will it be a problem to us? This informed decision to go into this particular research paper. Okay. We've talked about the ledger system. We've talked about how blockchain can work with the ledger system. So we won't really go much into that anymore. I'll quickly talk about some of the problem. Upon going around our system, our own ecosystem here, we observe that there is actually no research paper, no study that has been carried out on blockchain adoption for our capital market, despite its perceived opportunities and a few challenges here and there. So the objective of this paper is to investigate the prospects and barriers that the blockchain technology can have in the capital market. Then we'll also analyze the relationship between a dedicated blockchain influential group and the adoption. What this means is that for every blockchain adoption, we must have an influential group in every organization. If you don't have a group to implement this blockchain, there can be no point in adopting it. You understand what I'm trying to say? What that means is that, yes, we want to adopt this thing, but who are the people that will be targeted towards adopting it? Who are the people that will run that race of trying to adopt it? So that's what we're trying to do in our objective. Then we now propose strategies that will help us in this seamless implementation of this blockchain technology. What's our hypothesis? Because it was a very detailed work. We looked at the fact that is the market ready to adopt this technology based on availability of the implementation bodies, which I had mentioned earlier, or is it not ready? So that will form our HO and H1. So the gist of the work is to determine will the readiness be a function of the ability of the blockchain implementation body or not? So basically, the method we used was data collection, sending out questionnaires, receiving and sorting responses, and performing tests. So I'll quickly take it back to my colleague, Dr. Pius, so he can run us through how the data was collated and how the data was actually run through for us to get into our conclusions. Thank you very much.
Thank you.
Okay. Okay, I believe I'm back.
I confirm that you are, yes.
Oh, that's wonderful. Okay, now. So, like my colleague said, after collecting data, which was kind of difficult based on the timing, the whole pandemic thing. So we resorted to electronic survey. So we use what we call the survey monkey to actually get data from the respondent. So actually, the first thing we did when we got our data, it's basic practice and very good in a good way to actually ensure the reliability of the collected data. So we employed what we know as the Cohen-Kappa statistic. So we actually used two independent researchers, that's myself and my colleague, to actually go through the responses from the respondents, and then we ran this statistically to using the Cohen-Kappa statistics. Then when everything, of course, the minimum which we should expect from a Cohen-Kappa statistics is always 0.8, and we achieve more than this minimum. So on the average, I mean. Thereafter, we now wanted to look at, because we are now, like the hypothesis states clearly, we want to see how significant does the availability of blockchain implementation bodies in each of these capital markets, how does it really affect the adoption readiness? So for us to come up with this a statistically tested result, we employ chi-square, which is best for this because we are dealing with two categorical data features, I mean, which is the readiness and the availability of implementation bodies. So we also went ahead to use the phi value to test for our phi value, not only to see the relationship between these two features, but also to see the significance, the level of association between them, to be able to conclude that this is what is actually happening in the Nigerian market. So this is what we did for the methodology, and then the result we had for this, for the benefit, because we also got responses from the operators telling us the benefit they stand to get from adopting blockchain technology in the Nigerian capital market. And we got all this data from them. We can see, and graphically this is shown, and we see that a lot of the respondents actually affirm to the fact that the adoption of blockchain actually makes things easier for them with respect to the reconciliation of transactions and data when fully adopted. And also, we also asked for the barriers, what is actually hindering the full adoption of this wonderful and emerging technology in our Nigerian market. And these were the responses we got, and we represent this in percentages and in counts. And we also got this graphically, which is self-explanatory. And then point of interest is actually with our hypothesis to actually be able to confirm what we got from our observed data and from our expected outcome. And this clearly shows what we got with respect to our chi-squared analysis. And looking at this, our chi-squared value, the present chi-squared was 0.001, which is far lower than 0.5, which means in this case that we can accept our alternate hypothesis, which states that the availability of dedicated implementation bodies actually determines the readiness of adoption of this technology. Because in reality, without these bodies on ground to implement this technology, no matter how ready you are, it cannot be adopted and implemented seamlessly. So we are, like I said, we went ahead to look at the association level. To what degree does this actually determine the significance? And this value 1.01 actually shows that this is very, very strong dependency of this what do we call it, the implementation body with respect to the readiness of the adoption of the technology. So in conclusion, we can see that what the whole survey revealed to us was that a lot of the Nigerian market operators are aware of blockchain technology and its opportunities, though a few are also claim that they are not aware of it. And also a large number of respondents with respect to the operators actually think that blockchain might actually disrupt the day-to-day functioning of the Nigerian capital market. And that, to a large degree, is based on the fact that there are no available dedicated implementation body to make this process seamless and error-free. Next is the issue of the respondents that said that we are not actually ready, and in reality, we are not, because a lot of things need to be on ground, like the computerization of the whole market, Nigerian capital market. A lot of infrastructure must be upgraded, and so many other things. So these were some of the conclusions we drew from the analysis. And then we made our recommendations. And one of them is that for blockchain to be adopted, it depends largely on the availability of implementation bodies, because it's a very technical thing. Blockchain is it's no child's play. Implementing it seamlessly, it takes a lot of effort. So we need this that will see this implementation and maintain the deployment process. So recommend this before adoption can be done. Next, we also recommend that the regulatory bodies and the government agencies should actually make laws that will encourage this adoption, because right now the laws don't really favor the adoption of this technology in the capital market. And also, for a trivial technology like blockchain is, it's very resource intensive. It takes a lot of computing power. So especially if you're a miner, if you want to validate blocks and then do a lot of other blockchain stuff with mining, with respect to mining, you need a lot of computing power to do this. So we also recommend the upgrade of most ICT infrastructure in our Nigerian capital market. I think with this, we've come to the end of this presentation. Thank you so much for listening.
Thank you so much. I want to insist on the fact that we found the paper that was prepared for this colloquium absolutely excellent. So congratulations to the three of you. There are, and thank you, there are many questions. Unfortunately, we're running out of time, so I apologize. I will send you the questions in writing and give you an opportunity to answer them in writing or live on our next event. And we must now leave Africa and jump back to the Middle East. Again, thank you to the three of you, and congratulations on the quality of your paper and your presentation.
Thank you very much.
Thank
you very much. Thank you.
Our next speaker is Captain Adib Sartawi. He is joining us from Dubai live for a presentation on his work on the blockchain role across the modern supply chain. Captain Adib Sartawi also happens to be another one of our doctorate program student candidate. He is also a senior executive with over 40 years of experience as general manager for oil and gas, shipping, marine, ports development, management, logistics, and supply chain companies in the Middle East and in Europe. He holds a Master Mariner First Class Unlimited, which means foreign ocean-going abilities, from the Arab Academy of Science, Technology, and Maritime Transport. He is, again, pursuing his DBA right now at Ascensia Business School. Captain, a very warm welcome to you, and thank you for joining us.
Hello.
Hello, Captain. We can hear you okay, and you are now live on the colloquium. Welcome.
Thank you. Thank you. Good morning, ladies and gentlemen. I'm sorry I was disconnected suddenly after being with you for 2 hours, and when my turn came, suddenly I am off. It's my pleasure to be here with you guys. I would like to share the screen with you. As you can see, I'm jumping to page number 17 out of my presentation, which is about 32 pages. The reason for that is because, thanks to my colleagues, they have already covered most of the items I had put on the previous 17 pages, and there is no need to repeat the same things again.
If I may interrupt, Captain, we do not yet see your screen sharing. Can you try and share again?
Yeah. Do you see it now?
Excellent. Thank you very much.
Okay, great, great. My concentration here would be more on the sustainability of the blockchain within the application of the supply chain. and also to highlight one of the missing application in the blockchain, which is, or in the supply chain, which is the HSEQ, which is very, very important for the modern industry and the community. As we can see, it is meaningful to assess the use of the blockchain in terms of the specific requirement in particular business fields. The focus on three important practical implications. Number one, information sharing, traceability, and automation and digital transformations. These are three main important items in the supply chain, which really could be critical and a leverage for the supply chain activities. To give you one example of the supply chain power in real life, a few years ago in Walmart, one of the vice presidents came to the meeting room and he put on the table a basket of mango. And he said, "We will not leave the room until you tell me from where we got this mango." It took them about 6 days, 18 hours to find out where this mango came from. And nowadays, after Walmart start applying the blockchain system, this can take only the buttons of 2 or 3 buttons on the computers. Within few seconds, they can trace any commodity or products in their system. So you can imagine how much this is important in the supply chain and in particular in the food system. Issues which are expected to be solved by using the blockchain technology in supply chain management are as following. Not taking into account the transparency principle of the chain process, delays in supply chain process, lack of end-to-end traceability in the chain, deficiencies in audit process, difficulty in reconciliation between participants, which is very, very critical drawback in the supply chain. I am myself being active member of the supply chain through my 45 years of experience. I have witnessed all these problems. Lack of consistent and accurate information flow in processes. Any products now coming from China, which is the factory of the world, would always have a problem with consistency of information. Slow down in problem determination, action taking, and adaptation. Producing inappropriate or low quality products, services. Confidence problem among supply chain participants. Presence of manual and paper operation. Security issues in information system. Blockchain and supply chain sustainability. The economic sustainability. The market disintermediation. This is very important because normally when you are dealing in supply chain, you have mediators, and these mediators are costing more cost, and they are as well using time. So nowadays, the blockchain technologies offer this intermediation, which can support several business transactions by connecting buyers and sellers without the need of intermediaries. The flows of products and materials that are monopolized by fewer intermediaries may result in additional costs, increase the system complexity, and product rejection by customers. However, blockchain technology could help to overcome these issues by eliminating these mediators, serving as a central authority whose primary function is to validate transactions. For example, the Bitcoin blockchain system removes the third party that's concerned with monitoring the authenticity of cryptocurrencies transaction using a symmetric encryption. The combination of smart contracts and blockchain, which my colleagues already had explained, is a viable and workable solution to substitute intermediaries or trusted third parties in the case of transshipment operation in a global supply chain settings. Operational efficiencies. Blockchain can dramatically streamline entire business process and make the whole supply chain more responsive and efficient. Supply chain partners can eliminate several non-value adding activities as they will be able to see progress of goods and their movements along the supply chain. The track-back capability of the blockchain allows companies to quickly identify the inventory level of their products and raw materials and to make more integrated and well-informed decisions across all stages of the supply chain. As a result, blockchain technology has a time-saving advantage and can simplify many business tasks and eliminate inefficiencies resulted from the archaic processes, trade-related paperwork, complex bureaucratic procedures, and stringent institutional requirements. As noted, familiarity with the blockchain can lead to short task completion time, as we give in the example of Walmart, more simplicity, and enhanced jobs performance. Cost efficiency. The effective application of blockchain technology to supply chains can reduce several costs associated with the verification of product quality, the distortion of business process, and the transfer of ownership among supply chain partners. One of the important items in the transfer of ownership, which is very, very old classical, is the bill of ladings. Without bill of ladings, the ownership of 90% of the world wealth cannot be managed. The bill of lading is a very stringent document, which is similar as to the check, bank's check. Nowadays, to issue a bill of lading and to exchange a bill of ladings between a shipper in China and a consignee in Paris could take about 1 to 1.5 months, while by the blockchain, this may take less than a day or so. The disintermediate approach of blockchain can dramatically reduce the cost of transactions that were economically unfeasible. Moreover, the pressure to reduce the cost of products and services constitute an impetus for firms to use the technology for removing the overhead costs which are required for the exchange of assets. In our examples here, letter of credits could be removed from the transaction system, and as you know, letter of credits are very, very costly. The costless verification enabled by blockchain can benefit all the actors in the supply chain, though eliminating or reducing the cost related to the certification of products and their ingredients. As a result, supply chain partners would have the opportunity to generate significant saving in costs associated with the enforcement, such as labor expenses, legal fees, taxes, and court costs. Moreover, companies may realize cost savings from the reduction of waste and all adverse outcomes. Information on the blockchain can then be used to take proactive action, mitigate process frictions, and shorten the time to the market. All these savings are very, very valuable in the supply chain. Value creation opportunities. A promising application of blockchain is its potential to allocate resources among supply chain partners efficiently. As such, sharing models powered by blockchain technology allow businesses to have visibility into the availability of all underutilized logistic assets. For example, trucks, vehicles, machinery, equipments, warehouses, capacities. Likewise, blockchain has the appropriate digital capabilities to create a new world of collaborative and decentralized logistics, which host a vast network of supply chain actors matches firm on demand, and delivers improved availability and better utilization of logistic resources. Blockchain helps to create a fair economic business model and preserves the benefits of the sharing economy, because companies that are based on resource sharing will be under strict monitoring and scrutiny. The approach prepares the fertile ground for entrepreneurship and the development of new business ventures and companies. Unlike traditional IT platforms, blockchain can significantly contribute to the simplification of crowdfunding and the reduction of entry barriers and cost. This implies that both small and medium enterprises would be able to attract a cheaper capital and funding from investors all over the world. Regardless of their sizes, businesses also can majorly benefit from the economic incentives provided by the implication of blockchain. For instance, it is highly likely that the enforcement of intellectual property rights will increase the incentives to invest, create wealth and growth, and to generate competitive resources. Clear property rights would allow companies to add new businesses values and allow potential investors to increase their access to capital. Furthermore, firms have incentives to adopt blockchain technology because if not, they risk to be outperformed by their competitors, not live up to the expectations of their customers, and to lose the provincial financing, subsidies, and tax incentives that can be otherwise obtained as a result of increased transparency and disclosure of sustainable claim. Social sustainability. This is also a very important part of the role of the blockchain, which is being ignored as part of the blockchain role due to the high profile of the Bitcoins as a product of the blockchain. So many things are hidden or shadowed by this kind of mindset. Empowering trust. In business, you should presume that the other party could be untrustworthy and there is a risk of trust. Now, you don't need to address this issue at all. Trust is not an issue at all in the blockchain system. With the blockchain-enabled trust, supply chain risks and contingencies can be significantly reduced among exchange partners. The completeness and transparency of information and transactions on the blockchains constitute the necessary ingredients for establishing mutual, trustful relationship between supply chain stakeholders. This is vital and a crucial requirement for the supply chain success. So in business relation, blockchain solves the problem of missing trust between large number of untrusted stakeholders. Food safety. Food safety is a very important major public issue. Considering the potential of increased transparency, efficiency, and accountability, the blockchain-enabled traceability can provide. It is expected that there would be a significant reduction in healthcare costs and improvement in the public perception of the food industry. This will be reducing the spread of foodborne illnesses. The use of blockchain technology in development of agri-food supply chain traceability can secure all data entries regarding food products and allow end-to-end traceability of any food item that reaches the consumer in a quick time. For example, Walmart and 9 other firms, Nestle, Dole, Tyson Foods, Unilever, etc., have established business partnership to leverage blockchain technology in order to track and trace provenance so that they guarantee a food safety and more responsiveness to food recalls by increasing traceability. The source of any contamination during foodborne crisis can be quickly identified. resulting in low number of affected people and causing less anxiety and panic for consumers. Humanitarian cause and social empowerment. There is a tremendous potential for blockchain technology to make humanitarian aids more productive and agile. During times of crisis and disaster, the technology can be used to streamline the process of financial aids and eliminate delays caused by bureaucracy, paperwork, or political barriers, like what happened for supporting the Syrian refugees in Jordan, Turkey, and other refugees issues somewhere else. Environment sustainability. Blockchain technology can strengthen the ecological dimension of sustainability by reducing the environmental logistic footprint. By leveraging blockchain and smart contracts, it would be possible to incorporate several environmental protection and control initiatives through this careful monitoring of production parameters such as energy consumption, raw materials processing, and emissions. In this regard, Ashley and Johnson note that blockchain can simplify the participation of stakeholders in low carbon energy initiatives, facilitate the implementation of environmental protection program, and increase consumer access to clean energy. This is also another critical issue. As you know, an outcome from Paris Agreement between all the nations, we have to work toward eliminating the carbon footprint worldwide. Otherwise, the whole humanity is at risk.
Captain, I'm sorry to interrupt. We're getting to the end of our time slot. So if I can ask you maybe to give us your conclusions on your research on the role of blockchain across the modern supply chain in a couple of minutes. Thank you so much.
Yes, thank you. I have actually conducted a survey, which the link at the end of this survey I have conducted mainly in the Middle East area, and I have used the LinkedIn, and I got responses of almost 50 people, which are mostly of executive level, and we asked them several 7 questions about the supply chain and the blockchain applications, and the outcome was very exciting. The awareness of the supply chain, blockchain role in the supply chain is growing, but it is not yet good enough. Almost 20% are fully aware about the blockchain role, whereas 80% are still lacking that information. When we asked them about applications or possible applications of the blockchain into the supply chain, we found out that almost 40% of the respondents had confirmed that they will possibly use the blockchain in the future within their supply chain environment. And if we add the other 20%, which was in the middle of not sure, this will really cross the 50%, which is a very, optimistic findings that this is a significant approach for the blockchain to be more common use in the business transaction of the supply chain in the Middle East. Thank you.
Thank you very, very much, Captain Adib Sartawi, on all this research and information. And this is for me an opportunity to announce that all the papers, all the research, specifically what the Captain has presented to us this morning, will shortly be made available to all participants of this colloquium online. The link will be sent in a specific email after the colloquium is over and we have established the links on our available drives. Again, Captain, thank you very, very much for attending this colloquium today. And I hope you can stay with us for our next speaker, who will be the last one for this morning. Excellent. Thanks again.
Thank you.
Our next speaker is Daniel Maldonado Ruiz. Daniel is an electronic, networking, and information theory engineer for Escuela Politécnica Nacional in Quito, in Ecuador, and for the Master in Information Security Management of Universidad de Buenos Aires. He is an assistant professor, PhD candidate at Escuela Politécnica Nacional. His current investigations are about decentralization of user identities over communication networks and the autonomy of identities without centralized identity generators and the generation of new interactive systems related to blockchain to solve communication problems over the internet. Daniel, it's a great pleasure to host you with us this morning. I know it's very, very early in the morning where you are today, so thanks again for joining us today. I think your microphone is off. Daniel, we can't hear you at the moment.
Excellent. Good afternoon to all. It's good morning here. Just give me please 1 second. I may have a problem with the camera.
Well, we can see your PowerPoint, so don't worry too much about the camera. It seems to be working just fine.
It's working, my camera now?
We can see you and your PowerPoint presentation. Everything is in order.
Excellent. Thank you. So good afternoon to you all, and thank you for inviting me to this presentation. I'm about to present to you my proposal, my research proposal called 3BI ECC, a decentralized identity framework based on blockchain technology and elliptical cryptography. This presentation was published originally as a paper on the second conference blockchain research and application for innovative networks and services in Brains 2020, and its authors are Daniel Maldonado Ruiz and Jenny Torres from EPN in Quito, Ecuador, and Nourel Madoun from EPITA in Paris, France. The aim of this research is to solve the current situation of centralized identity management systems, where the security mostly lies on trusted parties. Both centralized and pseudo-decentralized identity systems need a system which tells the user who he or she is, assuring that there is no identity theft in their transactions. The main problems of these TTPs are always the existence of a unique point of failure in the form of central authorities, the mandatory dependence on the centralized infrastructure, and the inability of the user to create, control, and manage his own identity. Our proposal attempts to create a system based on free blockchains working on a secure vault for identity certificates. This secure vault formed by a primary blockchain, which is store all the certificates created for users, a secondary blockchain user used to store the revoked certificates to differentiate the valid ones from the revoked ones, and a core blockchain, which is a system which is created and stored its own certificates to create an autonomous network. The certificates are created by the users with ECC using some unique features of them as seed. The whole system will be used to manage the identities where user can store, revoke, and manage identities, or search other identity users in the system, turning the system in a pseudo directory one. This allows every user to use their certificates to communicate with web servers, file servers, or identity searchers, and also allow to some identity requirers to search or identify some users in order to communicate with them. That leads us to our proposal question. How does the creation of a technologically unified network with blockchain and elliptical cryptography support the generation and validation of the centralized autonomous system for communications over the internet? The main structure of our proposal is the creation of a core blockchain which is a blockchain inside the whole structure, inside every node of the network, used to avoid any central or external certification entity. This core blockchain generates self-signed strong certificates and stores them inside as an immutable secure vault. With that, the core will turn into the cornerstone of all the rest of the network, because the certificates stored in the core validate the other two blockchains with certificates stored as their primary records. The basic infrastructure of the proposal architecture is based on the integration of this framework with the current communication architectures in Escuela Politécnica Nacional. The institution has two main systems that manage all the identities. The identity manager itself, in which there are already created all the identities, because all the students and workers need to be registered with the records of National Identity Registration Office. The relationship between the institution and the identity manager, and the relation between the identity manager and the user are completely transparent, which implies all the user always interact with all the system without the need to manipulate or modify their inner identity features. The certificate manager will be replaced by our proposal architecture is in order to secure the identities already created, in order to have a secure communication system and an independent one. Inside the certificate manager, we have the full blockchain, in which we store all the certificates of the users. In the revoked blockchain, we have stored the revoked or expired certificates in order to establish a differentiation between both of them. The core blockchain interacts with the two previous ones, providing certificates to create a fully autonomous network. Finally, a relational software which acts like a gateway for the user as a originating. I'm sorry, I have some braces. Recently, I'm still hard to speak. Finally, the relational software which acts like a gateway for the user and an originator for storing and searching processes. All the system acting as a unique core interacts with the user and store the certificates in a form of smart contracts. The primary system that use this system is the email server and the document storage server, which are also related with the institution. Both systems use the certificate manager to create secure ways to perform each one of their functionalities. All of that replace any kind of centralized system, turning this network as an autonomous and independent one. The working flowcharts are designed based on the network of Escuela Politécnica Nacional also, and for the first proposal of this implementation, the identity is defined by institutional email, where email's password is considered as a seed. The creation flowchart explains how is created the identity certificate. The user receives a generic password where his email is created. When an email creates his own password, that password will be hashed, and that hash will be used as a private key. In parallel with a private key, it is created a PIN associated with identity to be used to simplify some operations that do not need strong identity validation, but still an identity validation. With the private key, the public key is created by ECC, and the result will be stored in the blockchain and associated with the identity of the user. In this case, the email and a creation timestamp. To the revocation flowchart, it is explained how the certificate is revoked when the user password is lost or hijacked. In that case, the user makes a request for a new password through an standardized interface, and the system creates a new generic one, from which the process I explained before starts over. That means the previous certificate will be stored in the reject blockchain, and the new one with the new timestamp will be considered valid. In the use flowchart, the entities that we use the system are, I speak before, the email system and the document cloud system. To use the security attributes, the user will validate his identity through his password. With the seed of the system, internally calculates again the user key pair. That on-the-fly public key will be compared with the public key stored in the main blockchain. If the calculated matches the one in the blockchain, the network validates the user and he can sign a document or cipher some file into the cloud. Then, if the calculated key does not match, the user will have 2 more attempts to enter the correct password. After that 3 attempts, the validation will be rejected, the connection closed, and the network will send an error message. In order to store the transaction generated when the user creates or validates their own identity on the blockchain, we propose also a consensus protocol which merge some features of proof of work and proof of stake to create a new system for consolidate certificated smart contracts in our network. The user communicates with the network via the administrative relational middleware software, which is acting like a gateway from all the network. The middleware manages the request but does not engage into the consensus protocol because it's not a node of the blockchain. Only acts as an originator from the consensus protocol when a request is received to be mined. That is in order to keep some transparency and neutrality over the network. The mining starts when the middleware chooses 2 random numbers to identify 2 random nodes. One performs the creation of the smart contract with the certificate of the user in order to be stored, and the other one will create the same smart contract in order to have a validation by repetition. By design, all the nodes into the network have not only the same priority, but also the same computational power. Both smart contracts validation are made in parallel for the blockchain network. This validation emulates the proof of stake features, and the random selection of equal nodes emulates the proof of work features. If both the smart contracts are the same, this transaction is stored in the full blockchain, and it is signed by the private key of the user and the private key of the field record of the full blockchain. To internal validation of the transaction will be used the nonce of the block, plus an internal ID of the new block created and the block ID for user validation. These validations, however, are only for logging purposes and not be part of the actual searching of the identities inside the network. If the comparison, however, were unsuccessful, the system will choose another 2 random nodes to perform the mining again. If after 3 attempts the comparison is still unsuccessful, the validation is rejected, the connection is closed, and the network will send an error message. That means the user needs to start again the previous request. With all of these flowcharts, we can define how the system will work with architectural proposal explained before. In the first time, the core self certification blockchain creates special certificates stored in the core blockchain, and some of them will be assigned to every other blockchain in the network, which means the core of the self-certification blockchain creates a validation for both blockchains in order to have a validation assigning processes without any third-party system. The user generates the self-certificated credentials via his unique self-data. That means the user uses their uniqueness with an ECC cryptographical suit to create an identity certificate. That means with the seed, users create a hybrid key only for themselves and a public key which be stored in the full blockchain. And the new consensus protocol starts by the administrative relational middleware software. If the user requests a revocation of one of these certificates, the middleware software will copy the selected block into the revoked blockchain and start a new certificate process without changing the identity of the requesting user. The relation middleware also performs all identity searches, both from users inside the network and or for third identity requirements like web servers, file servers, communication servers, or external users that need to communicate with internal ones. So we can define 3 types of processes: the ones started by the system, the ones started by the users, and the ones started by a third parties. So that is the function of our architectural procedures defined by our workflow charts. Finally, the main features of analysis of this proposal are full integration with the current security identity and communication infrastructure, meaning this framework will be integrated to the current network systems in the Escuela Politécnica Nacional. This proposal will use, as it's seen, specifically designed algorithms to deploy the core and identity blockchains. Also, the network allows users to change their password as many times as they need without modifying the identity by itself. And finally, the framework will be designed to provide transparency and security for the user in all communication. Our analysis of the proposal has several important features, like privacy, because only the public keys are stored in the blockchain. The private keys and the validation of the public ones are performed via cryptographic operations on the fly. Every node in the blockchain network has the same features and priority in all the network. On external view, all the network is a unique core. Also, our proposal intends to deploy a specific consensus protocol to identity systems to avoid fraudulent branches and not impersonation. This proposal also intends to define a special certificate with no relation with X.509 that could be oriented to identity features and not to the chain of certificates. Finally, we will define a specific identity and self-secure network to avoid every trusted third party creating an independent certificate network. That was our presentation. Thank you for your time, and I hope if you have some questions about it.
Thank you so much, Daniel, for this very, very interesting presentation. You have here an approach that is very technical in its essence, but if that's okay with you, I wanted to expand the field of your intellectual considerations by asking you a very general question. This morning, we have heard people coming from all over the world, from Dubai, from Lebanon, from Nigeria, from South America. And in the end, the question is that all of these different nations and these different governments are going to adopt very likely a very different set of rules and regulations and laws to regulate or not everything that is happening around blockchain. So my question to you, Daniel, is the following. Do you think that all of this can happen independently from government regulations, or do you think that some kind of world regulation should be put in place for blockchain, or do you think that it should be at the local, national level?
I think that's the first idea of my proposal, actually, because the idea is try to avoid some regulations, actually, not in the sense of have some illegalities or something like that, but giving the user, the citizen, the persons, which the people in internet, some autonomy in the working on the network. So I think it's very important to governments to have regulations in order to notice that this system are not used in a rogue way. But I think ask to the governments for these regulations could be a problem, because the main idea of using blockchain is decentralize of the uses in a supply chains or in an identity or even in cryptocurrency. So I think it's important to find a balance between the regulation that is always needed and the main idea of the blockchain, that is decentralization, and give people some autonomy of working or have their identity secure.
Thank you very much, Daniel, for this clear answer. And again, thank you so much for participating.
Thank you for
today
inviting me
in our colloquium. What time is it right now for you?
Right now is 6:30 in the morning.
It's time for coffee.
Yes, it's time for coffee.
Thank you so much, Daniel. I hope
you
you can stay with us this afternoon for the open table discussion that we are going to have.
Is that the round table in English?
It's going to be both in English and in French, but in all cases, it will be translated with subtitles made available.
Oh, great, because my French is really bad.
So is my Spanish. But technology compensates for our weaknesses.
Yeah, that's a good thing.
I want to say a great big thank you to our 8 participants for the very high quality of their contributions today. Noor, Yasmina, George, Anastasia, Captain Sartawi, Daniel. And I find it absolutely wonderful that we were able this morning to have intellectual contributions from France, Lebanon, Nigeria, Ecuador, Dubai. The works produced for this colloquium will be posted online and made available to all our participants. And I also want to thank you, that will be my final word for the morning session. I want to say thanks to Amina Wadbi and Natalia Ryabko, who are 2 of our full-time research faculty, for their assessment of the papers submitted and their help in general in making this colloquium possible. Thank you all for joining us for this morning session. We will be meeting in 1 hour and 30 minutes at 2 p.m. Paris time for the roundtable discussion and debate. Thank you all. See you in 90 minutes. Thank you for your participation.
Thank you very much.
Thank you, Guillaume. Thank you, Guillaume.
Thank you all.
Merci.